want to start with. So we're talking today about, how do we manipulate these things when we've got more than one power in a problem? How do we simplify? So there's all these different rules. I don't really care so much that you know the names of the rules. But the first one we're going to look at is what happens when you raise a power to another power. And that would look something like this, like x to the third, and then taking that and squaring it. Okay? So if you want to just start that first heading, raising a power to a power, and then that example, like 3 seconds to write that down while I pick a pretty color to write in. Okay, so what does this x to the third mean to do? Okay, that's x written out 3 times. Repeated multiplication is what powers does, right? So that's x times x times x. And then what is that square telling me to do? To do that exact same thing twice. So there it is once, and I'm going to do it again. And so altogether I have 6 x's. Do you agree with that? So I could write that as x to the power of 6. Now I don't want to have to do that every time. So what's my shortcut? What's my rule for looking at this and jumping to that? Okay, we multiply, right? So when raising a power to a power, we multiply the exponents. And I want to really emphasize here that these are rules that apply to the exponents. Okay, so when you have a number out in front of the variable, like you're going to see in this second example, that is not an exponent. Those are regular numbers, and those follow regular number rules. Take a second and write down these 2 examples if you haven't done that yet. Okay. That first example should be really easy. The second one, there's just one little thing I want to make sure you don't get caught up on. Okay, so we have n to the third to the 7th, 5x cubed, y to the 5th, z all squared. Okay. Let me see, we just started notes. Okay. For that first one, I would rewrite that as n to the 21st, right? So this would just be n to the power of 21. Now the thing I want to make sure that you don't get mixed up on in this next example is this. This 5 is a normal number, right? And just like normal numbers have always done, if I'm taking 5 and squaring it out here, what is 5 squared? 25. So I'm not multiplying there. Does that make sense that I'm actually doing 5 squared? Okay. But then all of my other ones are exponents, so what rule am I going to follow there? Yep, I'm just going to multiply all the way through, kind of like the distributive property. So this would become x to the 6th, y to the 10th, z squared. Because that z really has a 1 on it, right? Good. How many of you feel like you could have handled that second example before I even taught you anything? Like you already knew what to do with that. Good, then we're going to move faster. As fast as your little hands can write. Next up, multiplying powers. And there's our example we're going to do. Zoom that out a little bit. You should be writing this down. Anyone think they know the rule? Drew? Addition. Yeah, because here's what this is going to look like. I'm going to end up doing 3 x's and then times 4 x's. So altogether I end up with 7 x's. Okay? So when you're multiplying 2 powers together, you're going to end up adding the exponents. Okay? Add the exponents. And get your 2 examples down. We're moving right along. What I'm really hoping to get to is the mixed practice, but I don't know if we'll hit that today. Do the best we can. So what would that first one be? M to the 11th. Yep. Now in that next one, how am I going to combine the 5 and the 3? Okay, remember, those are regular numbers. This is a multiplication problem, so I'm going to multiply and make that a 15. And now I can combine my G with my G, and I get G to the 4th. Good. And how many H's? 7. Good. Still good, right? Okay. All right, if multiplying means you're going to add, what do you think dividing is going to make you do? Good. Subtract. Everyone got this? Slow me down if I'm going too fast. I'll this down. Next up, we are going to look at dividing. Okay, and I'm going to show you why subtraction is our rule. Okay, when you're dividing powers. Up on the top there, x to the 6 would mean to do 6 x's all multiplied together. Down on the bottom, I would have 4 x's all multiplied together. Right? Now what's going to happen? Okay, I am going to subtract 6 and 4. What I'm trying to get at is why does subtraction work? Looking at this, yeah, my x's cancel now, right? Like any place I have an x on top of an x, I get some canceling out. And what I'm left with is just the difference between the two. Okay, I'm left with however many more there were in the top than there were on the bottom, and that takes me to x squared. So when I'm dividing powers, I subtract the exponents. Okay, divide power, subtract the exponents. And there's your 2 examples that we'll try to hit today. So that first one, x to the 9th over x to the 5th, when I simplify that would just equal, good, x to the 4th. When I have problems like this next one, that are big and crazy like that, I usually find that it's easiest to kind of separate it ahead of time. Like, I know my numbers need to go together, my A's need to go together. Of course, this looks way uglier on the iPad screen. My B's need to go together. Okay? And so what do I do with the 16 and the 8? You actually divide them. Yep, you don't subtract those ones, you divide. So 16 divided by 8 is 2. And then this next one is a 5 and a 2, so I would have a to the 3rd. This is in case you can't see it, a 9 and a 3, so it would be b to the 6th. What about my c's? To the 3rd, right? Because that bottom one is really a 1. So 4 minus 1 is 3, c to the 3rd. Okay, good with that? Okay. Okay, did this division thing bring up any questions or wonderings for you? Anything that's going to keep you up at night? Clarence? There we go, that's what I'm looking for. What happens if we subtract, but our leftovers are on the bottom? And really, if we followed our subtraction rule, what kind of exponent would we get from that? A negative, right? So we're going to get to negatives in just a second. The first one I want to talk about is 0 exponents. How would 0 exponents happen? Garrett?
Not if they cancel out, but like if, I don't know how to say this.
You've got the right idea. It's sort of like canceling out, okay? What would happen with the exponents on top and bottom if I had a 0 exponent? Brendan, do you know?
Well, wait, I was just going to explain.
Oh.
So if you have 0 x's, how many x's do you have?
Well, that's true, except it's not quite the way it works. It'd be nice if it was that easy, right? Can someone give me an example of a division problem that would give me an exponent of 0? True? Okay, a to the 8th over a to the 8th, right? So a to the 8th over a to the 8th. Okay, of course, 8s are my hardest number to draw in here, but a to the 8th over a to the 8th is going to give me a 0 exponent, right? So this is going to give me a to the power of 0. But isn't this something where we have the exact same stuff on the top and the bottom? What does, yeah, doesn't that always equal 1? Like, for example, 5 divided by 5 would equal 1, right? X divided by x would just equal 1. So anytime you have the exact same stuff on the top and the bottom, it's going to equal 1. Now, Brendan, what you said is not wrong, because you're right that you would have 0 A's left here, but you got to make sure that you don't just say then it's a 0. It would actually be a 1, okay? Because when you do that division problem and you have the same numerator and denominator, that's going to simplify to be a 1. No A's anymore. It's not a to the 1, but it's just 1. Does that make sense? So anything to the power of 0 is just equal to 1. Okay? Not an exponent of 1, but just the number 1. Does that make sense? Okay, because it really means that all of your stuff cancels out, but in division terms, you still have the same on the top and the bottom. So, and I think, well, okay, yeah, we do have 2 examples, and they are a little different. So let's write them both down. So negative 4b to the 0, negative 2x to the 4th y squared all to the power of 0. First of all, other than the fact that the second one looks scarier, what's different about these 2 problems? Say it again. Okay, so this one, let's see, can anyone expand on that? I want to go somewhere with that, but I want to see if anyone else has anything to add. Lynn?
The difference is that this one has the parentheses, which means it's also putting the negative 2
Yes.
to the power of 0.
That's exactly what I was getting at. Which, Clarence, I think that's what you were saying too, but I wanted to get to that point. Is right here, this is negative 4 times b to the 0. So the only thing that's being raised to the power of 0 is the b. Does that make sense? Not the negative 4. But in this one, because this is all in parentheses, you're taking this whole thing and raising to the power of 0. Okay, that's going to make a difference in our problem. Because this one, this first one, is really now saying negative 4 times what? B to the 0 is equal to 1, and then that would just be negative 4.
What if b is 0?
0 to the 0? I feel like I
Isn't it, I did my calculator using here.
Okay, I was going to say, I feel like it's undefined for that reason, because we have 2 different rules. Anything to the 0 should equal 1, but then 0 to the anything should equal 0. So it is undefined. I would have to look up exactly what that's called or how they deal with that. But yeah, I think technically this rule, if I was being more technical, should say that the base can't equal 0. Good question, though. Really good question. Okay, does that make sense why that one would just be negative 4? Now in that next problem, I've got this whole giant mess raised to the power of 0. So what's the whole thing going to equal? Just 1, okay? So, but remember that top one's not going to cancel out entirely because only the b gets kind of canceled out there. Does that make sense? How am I doing on time? What time am I looking at?
45.
Okay, good. We can do a little bit of negatives today. Probably have to pick up with some more tomorrow. But are we feeling good so far? What if I gave you a quiz right now on just what we've talked about today? Like the examples we did. How would you feel? Pretty good?
Can you go over that last one again?
Sure. So I really didn't have to do anything because all of this is being raised to the power of 0. And anything to the power of 0 is equal to 1. So I could go through and say, all right, what's negative 2 to the 0? Oh, that's 1. This would become x to the 0, so that's 1. This would become 1 also. And then 1 times 1 times 1 is just 1. Under that negative question again. Can someone give me a division problem example where the exponent would come out negative? Okay. Okay, so 4 and 8, like x to the 4th over x to the 8th, something like that. X to the 4th over x to the 8th. So we know from our division rule that that would actually equal x to the negative 4, right? Because 4 minus 8 would give me negative 4. And I wrote it over here to the left for a reason, because I'm going to expand it over there on the right. Okay. So what really happens there is we're going to have 4 x's on the top, and you could probably visualize this a little bit. And then we have 8 x's on the bottom. So we are going to have 4 left over, but where are they located? The bottom this time, right? So our leftovers are down here on the bottom. And so we have x to the 4th, but we need to make sure that x to the 4th is shown as being on the bottom of a fraction. So what do we put up on the top as like a placeholder? A 1. If there's nothing else there, we would put a 1 up there. So just remember, all of this stuff in this chapter, because we're dealing with multiplication, when things cancel out, they don't actually equal 0, they equal 1. Because this is all powers, and powers have to do with multiplication. Multiplying by 1 is what cancels stuff out. Okay? So does anyone know what we would call the relationship between this and that? Between the beginning and the end? Starts with an R. Clarence, what did you say? Reciprocal. And I think I maybe heard it over here too, but it was so whispery I couldn't tell. Yeah, because this x to the negative 4, really I could picture this as being over 1, right? Because I can put anything over 1. So what negative exponents do is they make things move from the top to the bottom, or the bottom to the top. Okay, so negative exponents mean to take the reciprocal. And I always use the analogy, and it's a little childish, but it works, that right now, and by right now I mean like back here at the beginning, x to the negative 4. That x has a negative exponent, so it's unhappy. Okay, it doesn't like where it's at right now. Okay, so it needs to move. So it's going to move downstairs. Once you move it, now it's happy. And so then you have a positive exponent. So you can't leave negative exponents in your answers. You've got to always, I usually do all of the other simplifying that I can. And then just at the end, if I'm left with anything that's negative, then I start moving things around. Okay? So, couple of examples here. We'll do these 3 examples and then we'll call it good for today. Jot those 3 down. We'll go over them in just a second. Okay, so that first one, 4 to the negative 3 power, what that's really saying is to do 4 to the 3rd power, but put it where? Okay, it needs to be like on the bottom, because right now, if you're just given regular numbers, okay, it doesn't look like a fraction if you're just given like what looks like whole numbers, you can automatically assume that's like the top of a fraction, because we can always put it over 1 and make it a fraction. So this right now is over 1. We just never would really write it that way. We want to move it so that the 1 is on top, right? We want to move it so that it's like that. And then what is 4 to the 3rd power? It's 64. Remember, it's 4 times 4 times 4. Okay. Happens to the best of us. So 4 to the 3rd power is 64. So our final answer here would be 1 over 64. I cannot emphasize this enough, all right? And this being an A-track class, I hope this is going to happen less often. Negative exponents do not turn things negative. Negative exponents are traffic directors, okay? They move things around in a problem. Notice my 64 is not negative, okay? Negative exponents do not turn things into negative numbers. They just move things around in the fraction. So final answer there would be 1 over 64. All right, if we look at that next one, there's really nothing we can do right now to simplify other than move stuff around, right? Like I can't combine these two. And this is something I didn't say all the way through. I probably should have. Our rules that we have, like the multiplication rule and all of those, only work when what is true. Like why can't I just subtract these? They're not the same base, right? They don't have the same letter base. So it only works when I have the same base. So all I really need to do here is rearrange some stuff. There's 3 things in this problem. There's a 2, there's an x, and there's a y. Out of those 3 things, which one is unhappy where it's at? careful here.
Negative.
Okay, I heard the 2. Remember that this negative 2 here only applies to the x. Okay, so I have to look at these as like 3 separate things. There's the 2, there's the x, and then there's the y down here. So of those 3, now let me ask you that question again. Which one's unhappy? The x, right? The x to the negative 2. So this needs to move downstairs. Everything else is good where it's at. Do you agree that nothing else needs to change? So this is going to become 2 over x squared y to the 5th. Wouldn't matter actually which order you put the letters in down on the bottom. Okay, if you put the y first, it would not be a big deal. I usually just go in alphabetical order. Okay, and let's try one more. Okay, that last one. Does that look ugly to you? It is. Okay, when I have something like this, when I see negative exponents, I usually set up, when I go to write my answer, I set it up as a fraction. And then just as I'm doing the individual pieces, I decide, does this need to go on the top, does this need to go on the bottom? Okay? And I wouldn't worry about moving these things around until I deal with this negative 2 out here. Because sometimes, like, what's going to happen here is this is going to end up turning positive, right? So I wouldn't worry about moving this C down below because you're just going to have to bring it back up in a second. So I wait until I get to the end and then decide where stuff needs to go. So if I do 4 to the negative 2 power, what is that telling me to do to the 4? Square it and put it on the bottom. It's not going to turn negative, right? So 4 squared is 16, and I'm going to put a 16 downstairs.
Can you just FOIL it before you put that bottom instead of distributing?
You could, like, this wouldn't really truly be FOIL because it's not like something plus something inside the parentheses. So you could write it out twice and then flip everything. I guess that would work. Is that what you mean? Like to go through and square everything and then rearrange?
Or you square the whole thing? Wait, no.
Yeah, well, to square the whole thing, you're going to have to square each piece. So that's kind of what I'm doing right now. Okay? And then here, but you could absolutely write this, like you could write it out as 4 to the negative 2 and then b to the whatever, c to the whatever. And then after you write it, then move your stuff around. Yeah, you could do it that way. Okay, what's going to happen to my b? That's going to now be b to the what? To the negative 6, right? Because this is raising a power to a power. And our rule there was multiplication. So that is going to become b to the negative 6. And I'm just going to kind of make a note up here that this is b to the negative 6. But then in our answer, where should we put that b? On the bottom because it's negative. And once we put it there, it's not negative anymore. Okay? Because that negative only exists to tell you, hey, put me on the bottom. What am I going to get for c? Positive 8, right? So where is the c going to go? The top, yep. So I'm going to get c to the positive 8. 8's the hardest number to draw on this iPad. And then, is my answer good now? Is there anything else I could do to it? You want to check and make sure there's nothing else that can be combined and that there's no negatives anywhere. Because if there are negatives, you need to rearrange to make them positive. Okay, but other than that, we're good. How you feeling on that? Are the negatives the trickiest thing? Okay, that's the stuff we'll probably need more practice with later this week.